Have you ever worked on a distributed system thinking everything is perfectly set up, only to face unexpected failures that throw your entire project off course? Maybe you've been relying on the assumption that the network will always work as expected, only to find out that this is far from the truth. Well, you're not alone. As someone who's been knee-deep in enterprise-level software development for over a decade, I've seen how often developers and architects fall into this very trap. Today, we are going to dive deep into fixes of distributed computing, common mistakes that many of us still make, even after all these years. In this video, I'll be covering the top 8 mistakes of distributed computing, how they've evolved, and most importantly, what you can do to avoid them in your next project. Hello, and welcome back to my channel. My name is Latency, and on this channel, we talk about coding tips and tricks, software architecture, and helping you take your software development career to the next level. Today, we are jumping into one of the most crucial aspects of distributed computing, the fallacies that strip up even the most experienced developers. These mistakes have been around for decades, but they still catch us off guard every now and then. Let's start by breaking them down one by one. Point number 1, the network is reliable. At first glance, this seems like common sense, but despite what we know, we often assume that the network will behave like the way we expect. The reality, the network is not dependable. Hardware failures, server crashes, or even configuration errors that can cause breakdowns. You need to build systems that anticipate these failures rather than assuming everything will go smoothly. Point number 2, latency is zero. Latency is often underestimated or completely overlooked. When your application spans multiple servers and networks, you have to deal with delays in communication. These delays are inevitable, so you don't design your systems as if data moves instantly. Acknowledge that latency exists and build mechanisms to handle it. Point number 3, bandwidth is infinite. It's easy to think bandwidth is plentiful, but when you are dealing with large-scale distributed systems, it can become a bottleneck. Your network won't always handle large amounts of data seamlessly, and you should avoid assuming it will. Optimize data transfer and limit bandwidth-heavy operations to ensure smoother performance. Point number 4, the network is secure. Security in distributed systems is crucial. Never assume your network is secure by default. Always factor in encryption, authentication, and secure data transfer. Without these, you leave your systems vulnerable to attacks and data breaches. Point number 5, topology doesn't change. In distributed computing, you might assume that your network topology, how the network is structured, won't change, but it's rarely true. Networks expand, servers get added or removed, and that can affect how your application behaves. Be ready for adjustments, or be ready to adjust for these changes. And number 6, there is only one administrator. In many cases, we assume there is only one person or a team managing the system. In distributed computing, this is not always the case. Multiple admins or teams might be responsible for different parts of the system, which can lead to miscommunication or management issues. Proper coordination and documentation are key. Point number 7, transport cost is zero. And now this is my favorite one. Data transfer cost can add up, especially if you are working with large data sets. Don't assume moving data across the network is free. Keep an eye on the transport cost, especially if you are using cloud services. Point number 8, the network is homogeneous. Finally, assuming that all parts of the network are the same is a critical mistake. Different machines and servers may behave differently. Performance, speed, reliability can vary greatly. Now here's something we don't often talk about. Plan for failures. Even with all these precautions, failures can and will still happen in distributed systems. Whether it's a network failure, server going down, or data getting lost, your systems need to handle this gracefully. Implement retries, circuit breakers, failover strategies, and so on to ensure that when something goes wrong, your application doesn't crash. Being proactive about failures can save you headaches down the line. Now, as you work on your next distributed system, start thinking about how to design around these challenges. You'd be surprised at how much smoother things will run when you account for these fallacies. And hey, if you found this helpful, there's a lot more we'll be discussing about distributed systems, so keep an eye out for the next video. Stay tuned for more insights on making your systems more robust, and I'll see you in the next one. Ciao.